So welcome back everybody. If you didn't realize, we have come halfway through our 10 days Python course, and in today's session we are gonna talk about common modules in Python today. Alright, so let's get started with the content for today. So if you recall, I indicated in our first session that Python is a general purpose programming language, meaning it can be used to create a variety of different programs and that it isn't specialized for any specific problem or task. And you probably also remember this slide illustrating areas where Python is mostly used today. As you can see, there are many applications of Python. So now, after halfway through our course, you should be asking, how exactly are these tasks done using Python? We have only so far covered basic core concepts. And if we go back to the last slide, the only major thing I still have to cover is creating user-defined functions and introduction to object-oriented programming. Object-oriented programming by itself is like an intermediate level course. So in this day 9, I will just give you a brief introduction on what it means to have objects and creating objects and using them in a program. So the main concept that is left over is functions and objects, or object-oriented programming, after today's class, and then file handling most likely. So going back to this, we obviously won't be able to see everything that can be done by Python within this 10 hours of course that we have allocated. But today I want to show you how some of those work, or how exactly that works in practice, so that you can get a feel of some practical applications. After today's session, I want you to think back regarding this illustration here that you are seeing on the screen to appreciate how Python has its footprint rooted deeply in various IT-related tasks. So also recall that in first session, I indicated popularity of Python is driven by several different factors. And by this midpoint of our training, we have already realized some of those firsthand, especially the one highlighted here, like easy to learn and use. It's very beginner friendly and with simple syntaxes and very natural mimicking language. And the biggest of all, it's free. I want to highlight other three of them today. The core Python language itself is not that big, but we say that Python is versatile because it can be used for many different tasks, and that's why it is general purpose programming language. That versatility comes mainly due to the availability of wide range of libraries or modules that can be used to extend the basic feature of that core programming language itself. One of the reasons Python is so popular is that there are numerous powerful third-party libraries, usually created by Python community, to add functionality on top of the core programming language. We call these third-party libraries implemented as folder packages. We will learn about and use some of these packages in example today. But before that, let's understand a few basic concepts of modules and packages.
So, a quick question. So, is that the packaging and a library? Well, other programming languages also have libraries. So, what is the main difference between other programming languages, for example, Java versus Python?
They are okay. I will maybe in the next few slides you will get your answers. Okay, so maybe hold on for now. So let's understand a few basic concepts of modules and Python and packages in Python. If you quit from the Python interpreter and enter it again, the definitions you have made, like functions and variables, are lost. We had briefly talked about garbage collection in Python, if you remember. Therefore, if you want to write a somewhat longer program, you are better off using a text editor to prepare the input for interpreter and running it with that file as input instead. This is known as creating a script, and this is the approach we have seen so far. However, as your program gets longer, you may want to split it into several files or different parts for easier maintenance. You may also want to create or write a handy function and then simply use that same function in several other programs without having to copy its entire definition into each program. And to support this, Python has a way to put definitions in a file and use them in a script or in an interactive instance of the interpreter. Such a file is called module. So module is basically just a file containing executable statements as well as function definitions. The file name is the module name ending with .py extension. Definitions from a module can be imported into other modules or into the main module. It is customary but not required to place all import statements at the beginning of the module. So how we import a module is by using import command or keyword, and we will see a lot of examples later. The Python library is a collection of modules and packages that offer a wide range of functionalities. These libraries are usually created by Python community or organizations to solve specific problems or address common programming needs. As of today, July 1st, 2024, there are more than 550,000 Python packages available. So now you might be wondering, where do these module or library come from? Python comes with a library of standard modules. These modules are part of the Python distribution and are built into the interpreter. These provide access to operations that are not part of the core of the language but are nevertheless built in either for efficiency or to provide access to operating system primitives such as system calls, file input-output, and some mathematical operations. All modules in the standard library are available for use without needing to install anything extra. You might just need to import them into your script. Some examples may include datetime, OS module, JSON module, or HTTP module. In addition to the standard library, there is an effective collection of hundreds of thousands of components, from individual program and modules to packages and entire application development frameworks, available from the Python Package Index or PyPI. Python has a package manager called pip, PIP, that allows you to install these packages quickly into your system. So in the terminal window or in Colab Notebook, you can type pip install package name to install the package. After a bit of output, you can now import and go about using this package in your code. You as a developer also can create your own modules to encapsulate reusable code. These modules can then also be shared with a team or organization, or even publish it to PyPI for broader use. So what are some of the popular Python standard libraries? In this slide, I will quickly introduce you to some of the most popular and widely used modules from the standard library or Python standard library. And they include OS module. This provides a way of using operating system dependent functionalities like reading or writing to a file system. There is a sys module that provides access to some variables used or maintained by the interpreter and functions that interact with the interpreter. The datetime module supplies classes for manipulating dates and times. JSON module provides method to work with JSON data for encoding and decoding JSON files or any data in JSON format. The array module, which stands for regular expressions, supports regular expressions for advanced string matching and manipulation. The collection implements specialized container data types, providing alternatives to Python's general purpose built-in containers like dictionary, list, set, and tuples. Then there's itertools, which provides functions creating iterators for efficient looping. There's also function tools, which provides higher order functions that act on return or other functions. act on or return other functions. For example, decorators. And we won't cover decorators in our course. That's more advanced topic. There's also HTTP, which contains module for handling HTTP request and response, basically web requests and web responses back from server. And finally, there's random module that implements pseudo-random number generators for various distributions. And we will see a few examples of some of these modules, including the random module, later on. Okay, so those were some of the popular Python standard libraries. Now let's talk about third-party libraries. As I stated, there are more than 550,000 of these, so we won't be able to cover all of those. But here I'm trying to give you an insight on different tasks that can be done with Python and which module is more popular in doing those tasks. Okay, so it might take a while to explain all of these, so I'm just giving you a brief introduction of all of these 16 or 20 modules that I'm going to briefly talk about here. So let's take a look. For web development, we have modules, for example, packages or framework like Django framework, Flask, FastAPI, and Pyramid. These framework and libraries are used widely in the web development community for building and deploying web applications and APIs. For application and game development, Tkinter is the standard GUI toolkit for Python. It is included with the standard Python distribution and is used for creating graphical user interfaces. In Python, it is the most widely used module for GUI applications, making softwares. There are Kivy and PyQt that are also quite popular. One of my favorite is Pygame. It's a set of Python module designed for writing video games. It includes computer graphics and sound libraries and is built on top of the SDL library. Similarly, for web scraping, we have Beautiful Soup as one of the top libraries. Then there's also Scrappy Request and Request HTML, among others. So talking about Beautiful Soup, it is a library for parsing HTML and XML documents. It creates parse trees that are helpful for extracting data from HTML websites, and that is useful for web scraping. Request is a simple and elegant HTTP library for Python, but it's widely used for making HTTP requests. Request HTML is, think of it like a module, a request module on steroid, maybe. That's the best way to describe it. For automation and software testing, Selenium is the most popular one. It also does automating web browsers. It is often used for functional and regression testing of web applications. There's a new trend with Behave module, which stands for behave-driven. It is a behave-driven development, which stands as BDD framework for Python. So BDD is nothing new, but in Python, it is the Behave module is really the new, and Behave module is gaining a lot of popularity nowadays. This allows you to write tests in human readable format and integrates seamlessly with Python. Now, in a more popular, so NumPy is one of the top Python library, and it's a fundamental package for scientific computing in Python. This module is similar to MATLAB as it provides support for large multidimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. It is very vast due to its optimized pre-compiled C code. Very fast. So it has, because of the code are pre-compiled in C. It is, remember, C is compiled language, not an interpreter language, and Python is an interpreter language. So Python is slower than C. And in case of NumPy, these codes are pre-compiled in C, and that makes it much faster. And that's one of the reasons why NumPy is so popular. There are also other modules that depend primarily on this NumPy module. And then there are SciPy stat modules and SymPy that are also used often in mathematics and scientific computing. For data analysis and visualization, there are Pandas, Matplotlib, Seaborn, Plotly, and many more. Pandas is an open source data analysis and manipulation tool built on top of NumPy, like I said earlier. It provides data structure like data frames and series, which are ideal for handling and analyzing large structured data. So in combination, when we use these packages in combination, together they form Python ecosystem for tasks related to data manipulation, analysis, and visualization. I will give you one example of how this works later today. They provide powerful tool and visualization capabilities for exploring data, gaining insights, and presenting findings effectively. Then there is machine learning modules. Some popular machine learning packages in Python includes TensorFlow, PyTorch, Keras, and Skitlearn. Skitlearn is a popular lightweight machine learning library that provides simple and effective tool for data mining and data analysis built on NumPy again. Not just NumPy, but this is built on NumPy, SciPy, as well as Matplotlib. And that makes it very popular. Sorry. So TensorFlow is an open source deep learning framework developed by Google. This provides a comprehensive ecosystem for building and deploying machine learning models. On the other hand, PyTorch is an open source machine learning library developed by Facebook's AI Research Lab. This is known for its dynamic computational graph and ease of use, especially for research and prototyping. Keras is an open source software library that provides a Python interface for artificial neural networks. Keras acts as an interface for the TensorFlow library. And the last section I have here is image and natural language processing. Some popular AI packages dedicated for image processing and natural language processing in Python are OpenCV, SkitImage, NLKT, which stands for Natural Language Toolkit, and SpaCy. These ML and AI packages, machine learning and artificial intelligence packages, are widely used in AI community for various tasks including deep learning, natural language processing, reinforcement learning, computer visions, and many more. They provide powerful tools and pre-trained models to help developers and researchers build and deploy AI applications. So Prakash, does this presentation answer your question?
Yes, it does. Question.
Yeah.
I forgot what I was asking.
Okay.
Wait a minute. I think I forgot. I'll let you know.
Okay. Let me know when you, like, if it strikes back in your mind.
Okay.
All right, let's move on. So how do you load this module into your own program? Let's go ahead and see some example methods or different ways how we can import these modules. The simplest form is the import with module name. For example, random here is a module name, which is standard Python library. And by doing import is the keyword. And when we say import random in your program with modules name, like random in this case, this does not necessarily add the name of the functions defined within random. So random could be a py file, right? .py Python file, and there could be multiple functions or variables declared within that random module. or random.py file. And when you do random import random like this, it doesn't necessarily import or add the name of each of those functions defined within that module directly into your current namespace. It only adds this module named random there in your namespace, and using the module's name you can access the functions using dot notation. So dot notation is very important. We will see some examples later.
So random is a name of a module server, right?
Yes. Random is a module. It's basically a .py file, and it will have a lot of other functions that you can use, readily available for you to use. It also may have some definitions like variable names or whatever they needed. Okay.
Oh, okay. So random is an existing module.
Yes.
Okay.
It comes built in with your Python installation.
Okay.
So you don't have to reinstall it, or all you need to do is execute this import random script at the top. Doesn't even necessarily have to be at the top. Anywhere in your Python script, if you import random, you import those functionalities, and you can access those with the dot notation.
Okay.
There's another variation using multi-lines. So you can use this variation, word imports in multiple lines in your program to import more than one module at the same time. So in this case, you are importing cow, say, and then sys module with these two lines. This is also, there's also another variation of this. You can combine them in same line separated by commas. Another variation is import statement that imports names from a module directly into the importing module's namespace. So in this case, math module is math is the name of the module, and absolute or ABS is a function within that module, and pi is a variable that is also available or defined within that module. So when you do from math import apps and pi, you are only importing apps and pi. You are not importing the whole math module. Neither are you importing anything else from that module. Does that make sense? You only get access to these two, a function and a variable that was defined in this file.
Yeah. So you're importing the functions only.
Yeah.
Math module.
If you did import math, you would import everything from that math module. But here you are only importing
Correct.
two different things.
Right.
So when you do math would not be defined, but functions abs and variable pi would be defined in your namespace. Namespace generally means the working space that the file that you are you currently have open. There's another variation using asterisk wildcard. This imports all the names that the module defines, except those beginning with underscore. In most cases, Python programmers do not use this facility or its use is discouraged because it is using or importing everything in that module. It may introduce an unknown set of names into the interpreter, possibly hiding some things that you may have already defined. So there is what it is trying to say is, or what I'm trying to say is, if you import everything from a module, that may overwrite what you had already defined in your personal file. So by importing everything, now you're overriding your own previous definitions. So this practice is not a good way to import. The next variation.
You would simply import math instead of
Yeah.
saying,
yes.
Yeah. Okay.
The next variation is using as, which creates an alias for math. So m is a alias name for math, which is another name to call this math module, and you are creating that variable on the fly when you are importing this module. Whenever a module name is followed by as keyword, then the name following it is bound directly to that imported module. This is effectively importing the whole module in the same way the import numpy would do, or import math would do in this case, with the only difference being available as M, effectively renaming this module as we import.
Yeah, like the alias in SQL.
Yeah. The variable M now points to the math module object, which means we can't say math.py like we would do here, but we would be able to access pi using m.py instead of math.py. Some common example of this uses are import pandas as PD and import numpy as NP. There's also a variant to import specific things from the module and rename this as you are importing them. Most common example of this uses are from matplotlib import pyplot as plot, and we will see an example of this uses later. And last but not least, there's a variation of that as well. This is same as saying import matplotlib.pyplot as plt. So basically from this, what you can understand is matplotlib is a library, and in that library there could be a pyplot class. We haven't discussed about class yet, but you can think about this as a file that has multiple classes. Pyplot is one of those classes, and using a naming alias, we are trying to access all of that as just plt name. So that is all the slides or presentation I have. I'm gonna quickly show you this. This is pypy.org that I discussed. Are you able to see my screen? Blue webpage pypy.org.
Yeah.
Okay, so this is the portion that I want to highlight here. This is like a online repository of every module that is currently live on for Python. So you can see there are more than 550,000 projects, which are the modules itself. And you can search here, and from there you can go to specific websites for their tutorial for each of those packages. Okay, so easy to remember, pypy.org. That's where all the packages are. You can even add your package to this website if your functionality are well tested and useful, then it might gain popularity one day. So with that, let's take a look at some example exercises. I have here 3 sections: standard Python library module, third-party modules, and then custom built modules, just like in the PowerPoint or presentation I discussed earlier. So let's see example of Python modules. The random module has a lot of functionalities, and I'm giving you only 3 examples here just to give you an idea. I want to encourage you to go to random module and find whatever other functions that they have available for use. Okay, so first example here is a coin flip example. Here I have a list of 2 outcomes, heads or tails, and by importing random, again random is a standard Python library, so I don't have to do pip install to install this library. It's already pre-built with installation of Python. Especially in Colab, they handle all these already, including some of the third-party libraries that we do not need to install here in Colab, but we might have to install in other IEDs like PyCharm. Anyway, so here I'm importing that random module and then trying to access choice function of that random module by doing this dot notation, random dot choice. And it takes a list. In this case, the list only has 2 outcomes, heads or tails. And every time I run this, it will give me an outcome, like a coin flip. Every time there is a coin flip, it's either head or tail, right? So every time I run, there is a new random outcome out of these list of outcomes that are possible. Any questions on this? Pretty straightforward.
Can you run it again? See whether it gets tail. Oh, okay.
It's randomly giving, and all of these, by the way, are pseudo random, so it's not actually random. It depends on seed, which also you can define, given by random module, but I did not want to go there for this course. But all you have to remember is this is a pseudo random, not a real random number. Anyways, it does the job for us, right? So the next exercise, I'm simulating dice roll. So in this dice roll, there are 6 outcomes, and every time when I roll the dice, I should be getting integer value 1, 2, 3, 4, 5, or 6. So in this case, I'm doing rand integer or rand int, and if you look at this, it returns random integer in the range a and b, including both endpoints. So it will give 1, 6, and anything in between randomly. So every time I run this, it will give me a new number within that range, including 6 and 1. Okay. So another example here,
hold on a second.
Yeah.
Back to number 2. So what you're doing here is your input from random. You're importing randint, right?
Yes, random again has a lot of functions, right? Here we introduce choice.
Right.
But in this
Yes.
case, I'm only introducing rand int, and if I do random dot choice, I will get an error here because I'm not importing that, and
You're right.
this namespace doesn't know what choice is or what random is. It only knows
okay.
rand int.
Right. Okay.
Okay, so next one is shuffle function also in random module. So what I'm doing here is trying to create a half deck of card. So I only have A, J, K, and Q, and then all 4 faces like colors. Okay, so in a for loop or nested for loop, I'm creating or appending, concatenating nums with faces in different combinations of them. So I will get deck of card, and then I will shuffle them in place, meaning I'm not creating a new variable after shuffling. I'm shuffling the same list, cards list, and then printing them again. Okay, so here was my original list, and after shuffling, the same list came out like this. Pretty interesting, right? Now I can create a card game.
Your original list is where?
This original list, I started with a blank list, and I appended things in that in a nested for loop.
Okay.
I could do this in list comparison, but I was guessing that would create more confusions for you guys at this point.
Oh, okay. So you're printing cards, and then you're randomly shuffling it and print again. Okay.
Yeah, for each face, for each number, I'm appending face plus that number. So I'm looping over this, and then inside each loop, I'm looping over this.
How did you type the faces, like Chiria, heart, diamonds?
Yeah, these are like available Unicode that you can just use in Colab or any Python IDE.
Okay.
Yeah, I thought this example would be pretty interesting for you guys. Now you can think about creating a simple card game maybe, right? After this, all you have to do is use pop method to pop one last item from this list out. Maybe another pop method to pop another one, and then compare those two. See if both are J, then you get a duples or whatever, like a simple card game. Now let's move on. There's a statistics model, and I'm just quickly gonna run this. You by reading this code here, you already know it is going to give you mean, median, and standard deviation of this same list. So when I run this, I would get 90, 90, and 10 as the mean, median, and standard deviation out of those lists.
Okay, can you explain that code, please? I didn't get it.
So statistics is the module that I imported.
Exactly.
This module has a lot of other functions, including mean, median, and standard deviation functions.
Correct.
Right? When you hover your mouse over this, it will give you what that mean will do. If you read that,
okay.
it returns the sample arithmetic mean of data.
Okay.
And by data, this is the data that you are feeding that function into, right? Into that function.
Yeah.
And based on this data, the standard deviation, the mean and median are this.
Okay, so the mean is for the first one is 90 and the median is 90 and
the data is the same for all these commands.
Right,
80,
right,
80
right.
100 and 90. The mean and median happen to be same in this case.
Same.
The standard deviation is how far you are away from the mean. So the mean is 90, right? And these 80 and 100 are 10 points away from the median or mean.
Okay, got it.
That's just basic statistics. If you want to go into probability statistics or data science, you will need all of these concepts and much more. So next one is date time module. A simple print of current date here. When I run this, it will just give me current date and the time. Now you might be wondering which time is this? It's definitely not my current time here. Maybe this is the server's time, wherever the Google server is. It's July 2, so it's somewhere on the east, not in the US. Now let's move on to third-party libraries, a few examples. This one is pretty interesting, Causeway. So Python, this is a well-known package that allows a cow to talk to you, to the user. So since this is not a standard library, we would have to do pip install Causeway, and like before installing, if I try to run this, there will be an error. The module is not found, right? And it is trying to tell you the module may be there, so maybe install that first using pip or apt. Pip is more popular, so let's execute this statement and then come back to run this. So after some communication between the Colab server and this client that you are using, it says successfully installed this package. Now you can import and use that package. And when we run this, you are saying John Doe as a name, and the cow says hello John Doe. Pretty simple, just to show you how third-party libraries work.
So how did you download that again? It says
pip install Causeway. Causeway is the module name. Install is the command, and pip is the manager. Like you are using this manager to install this package.
Okay, so once you run it, then it will install, correct?
Yeah, once you click this is how we get. Like it will communicate with the server, download you the package, and in install after successful, it will show you that successfully installed the package. Now you can start using it.
Okay.
Now the next example I'm gonna show next few request, and request by the way is a third-party library, but Colab I think includes this in their package or the server. So maybe there's no installation required here. If it gives us error, we might have to install it, but we can try. JSON by the way is a standard Python library, so there's no installation required for that. So I'm here doing multi-line imports to combine standard library as well as third-party library. We could also do this with import request comma.json. It would be the same output, same outcome. But interestingly, what this does is it sends a request to this website and gets the data as a response, right? Saves that data, the response data, into this variable, and then using .json parser, I'm trying to fetch the BPI value, which is stored as the response is stored as a dictionary item. So with this index BPI, I'm trying to get the BPI value, and using this .usd inside that dictionary item is another dictionary item. So that's the index of USD. and then I'm creating this amount here to print out the current stock ticker for Bitcoin, and it gives me 62,873. So you might be wanting to know what is in this link. I can quickly show you. Just visit that link and it will just give you this JSON file or JSON as a response. And if you see, this is dictionary data type, right? So curly brackets, key value pair, if you remember that. So there's a dictionary inside this dictionary and then dictionary inside of that. So there are 3 layers of dictionary here. Now it's up to the user on how you can visualize this and correctly parse that into this amount using 3 levels of dictionary items. And after that, it's a simple print statement. Seems fairly complicated, but once you understand the data type, it's very easy. I think the price changed. Was it the same earlier? Yeah, it's changing, right? So based on live stock ticker amount, it is giving you the correct amount. That is a simple example of web scraping here using request module.
So is BPI something related to Bitcoin or something?
Yes.
What is? Okay.
Bitcoin price index.
Oh, okay.
Interesting example or not? I thought it was interesting enough. So okay, so here another example. I'm using aliases while importing modules to plot different data. Okay, so if you look at this, import numpy as np. So this np is alias of a numpy module, and then matplotlib.pyplot, I'm importing that as a simple plt. So this variable is referring to matplotlib.pyplot. Now where am I using np? I'm using it to create line space, random number between 0 and 100, or maybe 0 and 10, I forgot. But anyways, so np.sign will create a sign plot of that given x value. And then plt are the next few commands. plt.scatter will give me a scatter plot given the x and y values here. And then I'm simply creating x label and y label for the x-axis and y-axis, creating a title for that plot, and then showing that plot, displaying that plot out. So when I run this, it will get this nice plot. So this actually is creating 100 data, a series of data that are 100 length long, between 0 and 10. Any questions here? Okay. So next example is pretty simple. This custom module library, I'm just going to briefly explain you what is going on. I included an image in this. There's no code here except for that image. You as a developer, I told you earlier, can also create your own modules to encapsulate reusable code. So in this case, the reusable code are stored as 2 different functions. I'll discuss functions in the next session, but all you have to understand now is there are this def word is how you start definition of a function. The functions hello and goodbye are 2 different functions named inside this savings.py Python file. So this is a Python file with only 2 functions, nothing else in there, and those functions each are only have print statements in them, nothing else other than that. Now there's this main.py, another Python file in the same location that we had sayings.py. Okay, so there's a directory. In that directory there's sayings.py. In the same directory I have main.py. Now inside that main.py I am importing this another module that is in the same folder in this case. Now once I import sayings, I can have access to all these functions, right, that are inside the sayings Python file. In this case there are two functions, hello and goodbye, so I can say sayings.hello and sayings.goodbye, and these functions take one value as input parameters. So in this case that is this string, hello John Doe and Sarah. So when we run this Python file, the main.py Python file, it will look at this sayings.py Python file, get that definition from there, and use this value into those functions and get the print statements executed.
So how is main.py getting the value? I couldn't understand that. So
Which value?
in the first one you have def hello. That's one.
This is one function. Hello is a function
One
with
function.
with one input name, right?
Right.
And then
And
goodbye
there is
is
another function.
goodbye is similarly
Another
another function with also one input, also name.
Right. Okay. So on the right hand side, what is happening?
So here
If
first
you're
you imported
importing-
this file. So now you have access to these functions, hello and goodbye.
Okay. You imported sayings. Okay.
Yeah. So
And,
first you import this to get access to these functions, right? And how
Gotcha,
exactly do you
gotcha.
get
Okay.
access is by using this dot
Yeah.
notation.
Okay. Understand.
So sayings.hello will give you access to this function.
Right.
Saying.goodbye will give you access to this function.
Right.
And like again, each of those functions will take a string as input, and those are the strings here.
Yes.
And when you print, you get hello John Doe and goodbye Sarah. Pretty simple, but this gives you an idea on how you can use your own custom built Python module to import that later into your own code. Any questions on this? Okay, if there's no question, that is all for today. There are no assignments today, but there will be projects that I will be giving out after the next session. And again, in the next session, we will do a lot more exercise than this simple function that I showed you here as a glimpse. We will create a lot more functions, and then I will give projects in as a group for groups of 4 this time. So 4 of you will pair together or come as a group together and try to get a solution for the project. Any questions before we leave?
Not for me.
Yeah. Thanks.
Okay, thank you guys.